गुड मॉर्निंग। कल हमने बैलेंस्ड और अनबैलेंस्ड फोर्सेस तक डिस्कस करा था। कल वाली क्लास में हमने फोर्स, बैलेंस्ड और अनबैलेंस्ड फोर्सेस डिस्कस करे एंड व्हाट इज रिजल्टेंट फोर्स ये डिस्कस करा था। तो आज आगे कंटिन्यू करते हैं विद न्यूटन्स फर्स्ट लॉ ऑफ मोशन।
There was no external force acting on the bike when the rider stopped pedaling. So why didn't the bike stop? Here is another activity for you to observe. If you pull out the cardboard with a jerk, the coin will drop into the tumbler. Why doesn't the coin get pulled away with the cardboard? Both the phenomena that you just observed can be explained through the law of inertia, also called Newton's first law of motion. Newton presented three laws that govern the nature of motion. These laws are derived from Galileo's ideas and experiments. Let's take a look at Galileo's experiments with inclined planes. Consider a marble resting on a plane inclined on both sides. Now, the marble is released from the left, that is, end A. The marble rolls down the slope and travels up the other slope till it reaches the same height from which it was released. In this case, the inclinations of the planes on both sides were equal. Therefore, the distance covered by the marble rolling down was the same as the distance it climbed up on the other plane. Let's see what happens if the angle of inclination of the right-hand side of the plane is gradually decreased. The marble travels a longer distance till it reaches its original height. The angle of inclination of the right-hand side of the plane has been reduced to 0. The plane is horizontal. How far will the marble travel now? It travels quite a distance. The marble stops eventually because of the frictional force opposing its motion.
So in the last case, angle of inclination has been reduced to 0, and in this case you can see that marble has traveled quite a long distance. But उसके बाद क्या होता है, frictional force एक्ट करने लग जाता है जिसके कारण marble stop हो जाती है.
In practical situations, it is difficult to achieve zero unbalanced force because of frictional force. However, friction can be minimized by using a smooth marble on a smooth surface and using lubricants. If the surface of the plane was completely frictionless, the marble would travel forever, trying to reach its original height. Thus, a marble in motion would keep moving if unbalanced forces or the net force on the marble was 0. From this, Galileo deduced that an unbalanced external force is required to change the motion of an object.
So, from this, it was stated that an unbalanced force is required to change the motion of an object. Unbalanced forces were clear to you in the last class, that when unequal amount of forces were applied, then that force is unbalanced force.
But once the object starts moving, the application of no net force is required to keep it in uniform motion. Consider the example of spacecraft Pioneer 1, launched about 20 years ago. Deep in space, it keeps moving even without the aid of engines, because there is no frictional force in space to stop it. The tendency of undisturbed objects to stay at rest or to keep moving with the same velocity is called inertia.
So what is inertia? It is the tendency of the undisturbed objects to stay at rest or to keep moving with the same velocity.
Newton's first law of motion states that an object remains in a state of rest or of uniform motion in a straight line unless compelled to change that state by an applied force. That's why the first law of motion is also known as the law of inertia.
What is the other name of first law of motion? It is also known as law of inertia.
Can you think of some real-life applications of this law? Well, consider the concept of wearing safety belts in cars. Why do we need these belts? When a car is moving, we are at rest with respect to the seat, but moving along with the car with respect to the road. In the unfortunate event of a car crash, the car may stop suddenly. Even when the car stops, our body tends to continue in the same state of motion because of its inertia. Without a seatbelt, our bodies would either slam into the steering wheel at a high speed or
राज तो सेफ्टी बेल्ट्स क्यों पहनना चाहिए? बिकॉज जब कार मूव कर रही है तो कार के साथ साथ हमारी बॉडी भी उसी मोशन में है, बट अगर एक्सीडेंट हो जाता है तो कार स्टॉप हो जाती है, बट हमारी बॉडी मोशन में ही होती है. अगर हम सीट बेल्ट्स नहीं लगाएंगे तो हमारी बॉडी फॉरवर्ड डायरेक्शन में मूव करेगी, जिसके कारण पर्सन को इंजरी हो सकती है.
go flying through the windshield, causing injuries from the impact. Another common example you can see in countries like India is the game of carrom. Attempt a hit at the bottom of a pile of coins. With a strong hit, the bottom coin moves out, while the other coins in the pile fall vertically to the table. This is because of inertia of rest. Can you now use the law of inertia to explain why the bike doesn't stop immediately when you apply the brakes? The coin over cardboard falls into the tumbler when the cardboard is pulled out. The bike doesn't stop immediately because of inertia of motion. However, it stops after a while because of the opposing force of friction from the road surface.
तो आप लोगों को क्लियर हो गया कि बाइक स्टॉप क्यों नहीं होती? बिकॉज इनर्शिया ऑफ मोशन के कारण जब आपने इसमें ब्रेक्स लगाया तो ये तब भी स्टॉप नहीं हुई. उसके बाद ये कब स्टॉप हुई? उसके बाद फ्रिक्शनल फोर्स अप्लाई हुआ ऑपोजिट डायरेक्शन.
In the absence of this frictional force, the bike would have continued running, rather like a satellite.
तो अगर फ्रिक्शनल फोर्स अप्लाई ना हुआ होता तो बाइक जो है कॉन्टिन्यूसली मूव ही करती रहती. इज इट क्लियर टू यू?
Similarly, the coin falls into the tumbler because of inertia of rest. So far, we have considered inertia in terms of rest or the speed of an object. But velocity refers to direction as well as speed. When a car takes a turn at a high speed, you are thrown to one side. Why does this happen?
So now the question is asked to you. We have already discussed in our chapters. Why are you thrown to one side when a car takes a turn at a higher speed? जब कार टर्न करती है तो देखो पर्सन इस साइड पे फॉल हो गया. तो ऐसा क्यों होता है क्लास?
Because, owing to inertia of motion, your bodies want to continue traveling in a straight line. The engine is applying an unbalanced force to change direction. Our inertia makes us slip to the side of the seat opposite the direction of the turn. Discuss in groups the answers to these questions.
So here the question is given, why is a groove provided in a saucer for placing a cup of tea? If the groove was not there to hold the cup in place, any sudden movement of the saucer would make the cup move as well. Owing to inertia of rest, the tea would try to resist and would spill out of the cup. अगर ग्रूव ना होता, सी जो प्लेट होती है उसके बीच में आपने देखा होगा हल्का सा थोड़ा सा टर्न होता है कप को प्लेस करने के लिए. अगर वो ना होता तो क्या होता? अगर हल्का सा भी मूवमेंट होता तो उसके कारण कप मूव करता, बट जो टी है टी उस मोशन को रेजिस्ट करती. ओइंग टू इनर्शिया ऑफ रेस्ट, टी वुड ट्राई टू रेजिस्ट एंड वुड स्पिल आउट ऑफ द कप, जिसके कारण टी गिर सकती थी. सी इफ द ग्रूव वाज नॉट देयर टू होल्ड द कप इन प्लेस, अगर ग्रूव ना होता कप को होल्ड करने के लिए, एनी सडन मूवमेंट ऑफ द सोर्सर वुड मेक द कप मूव एज वेल. और हल्का सा भी मूवमेंट होता सोर्सर का तो कप भी मूव करता. ओइंग टू इनर्शिया ऑफ रेस्ट, द टी वुड ट्राई टू रेजिस्ट, और इनर्शिया ऑफ रेस्ट के कारण टी जो होती उस मोशन को रेजिस्ट करती और स्पिल इट विल कप के बाहर गिर जाती. ठीक है. Next question is, why do we tend to fall backward when a bus starts moving suddenly? जब बस अचानक से चलने लग जाती है तो हमारी बॉडी पीछे की तरफ क्यों फॉल होने लगती है? Owing to inertia of rest, our bodies tend to resist the sudden motion and stay back. क्योंकि हमारी बॉडीज तो क्या होती है, रेस्ट पर होती है, तो वो इनर्शिया ऑफ रेस्ट के कारण हमारी बॉडी मोशन में आने के लिए रेजिस्ट करती है, जिसके कारण अचानक से पीछे की तरफ फॉल होती है. और अब आपको बताना है कि what happens when a bus stops suddenly. जब बस अचानक से रुक जाती है तो क्या होता है? Our bodies are thrown forward as they are in inertia of motion. हमारी बॉडी आगे की तरफ गिरने को हो जाती है because inertia of motion के कारण, and want to continue their forward motion even though the bus has stopped. बस के स्टॉप होने के बाद भी हमारी बॉडी उसी मोशन में रहना पसंद करती है.
The boy is able to kick and move the football easily, but not the stone. That's because the inertias of all objects differ. Heavier objects have more inertia. In other words, heavier objects offer more resistance to a change in the state of rest or motion. What would be easier to pull forward? A bicycle or a truck? Why? The bicycle is lighter and hence offers less resistance or inertia to being made to move from a state of rest. Thus, the mass of an object can be said to be the measure of its inertia.
So class, this topic is mass and inertia. मास और इनर्शिया आपस में किस तरह से रिलेटेड होते हैं. मैंने आपको ऑलरेडी बता रखा है कि जितना ज़्यादा बॉडी का मास होगा उतना ज़्यादा इनर्शिया ऑफर करेगी जो. द मास ऑफ एन ऑब्जेक्ट इज द मेजर ऑफ इट्स इनर्शिया. आप देखो कि जैसे लास्ट हमने देखा था, एक बॉय था जो एक बॉल को पुल कर रहा था और एक स्टोन को पुश कर रहा था. ठीक है, बॉय बॉल को पुश कर रहा था और एक स्टोन को पुश कर रहा था, बट स्टोन को पुश कर पाना बहुत मुश्किल था बिकॉज जो इनर्शिया होता है वो मास पर डिपेंड करता है. मास जितना ज़्यादा होगा उतना ज़्यादा इनर्शिया होगा. So what is inertia? Tendency of undisturbed objects to stay at rest. So, tendency of undisturbed objects to stay at rest or keep moving with the same velocity is inertia. Inertia of rest or inertia of motion. Newton's first law of motion or law of inertia. An object remains in a state of rest. कोई भी ऑब्जेक्ट अपनी रेस्ट की स्टेट में रहेगा या फिर यूनिफॉर्म मोशन की इन अ स्ट्रेट लाइन अनलेस एंड अनटिल उसको अपनी स्टेट चेंज करने पर कंपेल ना करा जाए बाय एन अप्लाइड फोर्स. An object remains in a state of rest or uniform motion in a straight line unless compelled to change that state by an applied force.
When the striker hits the carom coin stack, only one coin is set in motion. The other coins are intact. Why does this happen? The bicyclist has stopped pedaling, but the bicycle continues to move. What is the reason for this? Why does this happen? Both these happen because of inertia. Inertia is the tendency of an object to resist change in its state of rest or motion unless acted upon by a force. When the striker hit the bottommost coin of the stack, only that coin changed its state of rest and came in motion, while the rest of the coins were intact due to inertia. Similarly, if an object is in motion, it continues to maintain the same speed and direction of motion unless acted upon by a force. When the bicyclist stopped pedaling, the bicycle continued to move due to inertia. The bicycle moved until the force of friction stopped it. The resistance to change shown by the coin stack is not the same as that shown by the bicycle. So are these both the same kind of inertia, or are there different types of inertia? Let us take a bus ride to understand this better. As the bus starts to move, your head is pushed backwards. Let us see why this happens. When the bus was stationary, your body was at rest. When the bus started moving, your feet, which touched the floor of the bus, started moving simultaneously. But your head exhibited a type of inertia called inertia of rest. Inertia of rest is the tendency of an object to continue in its state of rest. If the moving bus stops suddenly, will your head be pushed backward due to inertia of rest? Let us find out. If the moving bus stops, your head is pushed forward. Well, do not be surprised. This time it is because of inertia of motion. When the bus stopped, your feet came to rest simultaneously. But your head continued to move with the same speed and in the same direction in which the bus was moving, due to inertia of motion. Inertia of motion is the tendency of an object to continue moving at the same speed in a straight line. What would happen if the bus takes a left turn? Which type of inertia will affect your head? Let us find out. When the bus takes a left turn, your head tilts towards the right. This is because of inertia of direction. Inertia of direction is the tendency of an object to resist a change in its direction of motion.
तो अभी तक क्लास हमने क्या पढ़ा? इनर्शिया ऑफ रेस्ट, इनर्शिया ऑफ मोशन और इनर्शिया ऑफ डायरेक्शन. क्लियर हो गया? जब बस ने कॉन्टिन्यूसली जब बस ने मूव करना स्टार्ट करा, पहले बस रुकी हुई थी, स्टेशनरी थी, तो हमारी बॉडी भी स्टेशनरी थी. उसके बाद बस ने मूव करना स्टार्ट करा, जिसके कारण क्या हुआ? हमारे फीट तो मोशन में आ गए, बट हमारी बॉडी क्या थी? रेस्ट पर थी. इसलिए सडन जर्क लगा हमारी बॉडी. ठीक है, जर्क यानी धक्का हल्का सा. उसके बाद है इनर्शिया ऑफ डायरेक्शन. इनर्शिया ऑफ डायरेक्शन क्या होता है? ये टेंडेंसी है किसी ऑब्जेक्ट की टू रेजिस्ट अ चेंज इन इट्स डायरेक्शन ऑफ मोशन. व्हाट इज इनर्शिया ऑफ डायरेक्शन? इट इज द टेंडेंसी ऑफ एन ऑब्जेक्ट to resist a change in its direction of motion.
So, while the bus turned left, your head continued to move in the straight direction. This causes your head to tilt towards right. We know that all objects exhibit inertia. But do some objects exhibit more inertia than others? Yes, they do. This is because of the relationship between inertia and mass. Try pushing a motorcycle and a car. Which is more difficult to push? The car is difficult to push. This is because the car has more mass than the motorcycle. Therefore, more the mass, greater is the inertia exhibited by that object. Let us do a quick recap. Inertia is the tendency of an object to resist change in its state of rest or motion unless acted upon by a force. There are three types of inertia. Inertia of rest, inertia of motion, inertia of direction.
inertia of motion and inertia of direction.
Let us do a quick recap. Inertia is the tendency of an object to resist change in its state of rest or motion unless acted upon by a force.
So what is inertia? Inertia is the tendency of an object to change its state of rest or its state of motion unless and until it is acted upon by some force. I hope कि आप सबको inertia क्लियर हो गया होगा. inertia क्या होता है? तो inertia आपको क्लियर हो गया होगा. और इससे पहले हमने पढ़ा inertia और मास के बीच में रिलेशन. जैसे हमारा मास, अगर हमारा बॉडी का मास लार्ज है तो inertia भी ज़्यादा होगा. अगर बॉडी का मास कम है तो inertia भी कम होगा. ठीक है, हमने पढ़ा था जैसे ट्रेन का एग्जाम्पल पढ़ा था और एक कार्ट का एग्जाम्पल पढ़ा था. जैसे ट्रेन का मास ज़्यादा है तो inertia क्या होगा? ज़्यादा. और इसी तरह से अगर कार्ट का मास ट्रेन से कम था तो inertia कम होगा. तो inertia और मास जो है डायरेक्टली प्रोपोर्शनल है एक दूसरे के. तो inertia की डेफिनेशन आप लोगों को क्लियर होगी. inertia के टाइप्स: inertia ऑफ रेस्ट, inertia ऑफ मोशन एंड inertia ऑफ डायरेक्शन. और इससे पहले हमने करा था न्यूटन्स फर्स्ट लॉ ऑफ मोशन. सो न्यूटन्स फर्स्ट लॉ ऑफ मोशन को और क्या कहा जाता है? लॉ ऑफ इनर्शिया. विद दिस हमारा न्यूटन्स फर्स्ट लॉ ऑफ मोशन हो गया आज और इनर्शिया हो गया. इनर्शिया और मास के बीच के रिलेशन हो गए. तो क्लास आगे का कल कंटिन्यू करेंगे विद इनर्शिया, विद न्यूटन्स सेकंड लॉ ऑफ मोशन. इज इट फाइन टू यू? आई होप आप लोगों को ये कॉन्सेप्ट क्लियर हो गया होगा इनर्शिया एंड मास का और न्यूटन्स फर्स्ट लॉ ऑफ मोशन का. तो हमारा फोर्स डिस्कस कर लिया हमने, बैलेंस्ड और अनबैलेंस्ड फोर्सेस डिस्कस कर लिए और न्यूटन्स फर्स्ट लॉ ऑफ मोशन डिस्कस कर लिया. ओके, थैंक यू.